Hi there, this is Anastasio G. Pantaleon Jr. and welcome to my YouTube channel. In this video, we will be learning about linear interpolations in finding values in tables. So let's define first the interpolation principle. Linear interpolation is the simplest method of getting values at positions in between the data points. The points are simply joined by straight line segments. Each segment, bounded by two data points, can be interpolated independently. So what you mean by that is that, for example, this is your x and y axis. Okay. Now, suppose you are given the value of the first point. First point is 1x and have 1y coordinate. Okay. The other point is, the second point is 2x. Okay. And we have the 2y. So these are the first two values that are given. And what do you mean by that is that at positions, okay, in between the data points. So that means if you are about to find point 3 here, with having a value of 3x on the x-axis and a value of 3y in the y-axis, it all has the same slope. Okay? As you figure it out in your slope of a line from your algebra, y a b plus, oh no, I mean ax plus b. Okay, this is the slope. So this is the constant line, okay, where the slope is equals to rise over run. What do you mean by that is that the value is 2y minus 1y over 2x minus 1x. And it's the same as, say, 3x minus 1, 1y. The 3y is the same as minus 1y, and 3x minus 1x. And it's also the same as, say, 2y minus 3y over 2x minus 3x. So hope you remember your algebra. Okay. Now for the application. So there are a lot of applications of interpolation, including the statistics, how to find the value of z-scores, t-scores. But in this example, in this video, we will be using the superheated vapor of water vapor as an example. Okay, now suppose you are tasked to find the pressure, the values of specific volume, internal energy, enthalpy, and specific entropy at a pressure of, say, 2355 kilopascal and at a temperature of, say, 525 degrees Celsius. Now, some of your tables only give limited information, like this one, you are only given 2000 kilopascal and it jumps to 2500 kilopascal. So you cannot find the 2355 kilopascal. And also, the temperature is 500 degrees Celsius and the next value is 600 degrees Celsius. And you have to find the value of uh, a specific volume, a specific internal energy, a specific enthalpy, a specific entropy at 525 degrees Celsius and at a pressure of 2355 kilopascal. So there are methods, or there are many two ways on determining the values. We have the vertical and the horizontal. In this example, we will be doing the horizontal first. We have to find what's in between, what's what's the value of 525, which is in between 500 degrees Celsius and 600 degrees Celsius. So we have to squeeze through. So this is 525 degrees Celsius. And this in between is 2000 kilopascal and 2500 kilopascal. So we have 2, 3, 55 kilopascal. Okay. Now, to make it easier for us, we have to designate subscripts. Okay. For 525, we subscript it as A. 2000 kilopascal, we have B. Say 2500 kilopascal, we have to designate this as C. And 2355 kilopascal, we have to designate this as D. Such that we designate specific volume at 525 degrees Celsius and at 2000 kilopascal. So this means VAV. The same as true with the internal energy. U at 525 degrees Celsius and at a pressure of 2000 kilopascal. Okay, it's the same with this one. AB, SAB. Also, in the 2500 kilopascal or C, so you have your specific volume at VAC, which means that specific volume at 525 degrees Celsius and at a pressure of 2500 kilopascal. So we have the internal energy of at a temperature of 525 degrees Celsius and at a pressure of 2500 kilopascal. So VUAC, HAC, and SAC. So to find VAB, therefore, we have to interpolate like this one. Clear all. Say 525 minus, say, 500 over 600 minus 500. We equate that to, say, VAB, okay, minus the value of this one. So we have 0.17568 over the value of specific volume at 600. So we have 0.1996 minus 0.17568. This would be equals to, okay, we have this one will be 0.25. So we arrange that. This one is 0.25 times 0.1996 minus 0.176 or 17568, okay, equal to VAB minus 0.17568. So your VAB becomes 0.18166. So that is your specific volume in meter cube per kilogram. So those we have to have this value VAB, which is equals to, say, okay, it's 0.18166, like that. So again, we have to find the value of the VAC, specific volume, at 525 degrees Celsius and at 2500 kilopascal. So it's the same. 525 minus 500 over 600 minus 500. This is equals to 0.25, of course. And that the value of your VAC minus 0.13998 all over 15930 minus 0.13998. I made this one point, so this is point, sorry, okay, those making your VAC equal to 0.1448225 meter cube per kilogram. So we now substitute that in this value, okay. So that means this is 0.1448. So the two values are given, and we want to find, say, V. What do you mean that? VAD, okay, which means that a specific volume at 525 degrees Celsius, which is A, and 2355 kilopascal, which is D. So now the interpolations happen at vertical. So that means at a pressure na. So we have 2355 kilopascal minus 2000, okay, all over say specific volume. I mean the ratio of 2500 minus 2000, which is equals to say 2355. So the value of that is your specific volume at VAD minus So what is your 2000 kilopascal? Value of specific volume, we have 0.18166 over 0.1448 minus 0.18166. So therefore, the value of your VAD is equals to 0.1555, which is in meter cube per kilogram. Okay, so we have to insert that here. Okay, so we have the value of your VAD somewhere here. VAD is equals to 0.0, ano I mean, sorry. Okay, value of your VAD is 0.1155. So that means that the specific volume of your steam at a temperature of 525 degrees Celsius and at a pressure of 200 or 2355 kilopascal is equals to 0.1555 meter cube per kilogram. And so again, you have to find the internal energy UAB. So UAB, internal energy at 525 degrees Celsius and 2000 kilopascal. So that is, we say 525, okay, minus 500, 600 minus 525 is equals to UAB minus 3116.2 all over 3290.93, okay, minus 3116.2. Okay, so the value of your UAB, UAD, I mean, this is D. UAD is equals to 3159.88. Sorry, I overlook it as UAB. This is UAB. Okay, I stand corrected. Okay, so we erase that UAB and substitute values. Okay, as 3159.88. That is in kilojoules per kilogram. So it's now time to find the value of UAC, this one. So UAC, so we have 525 minus 500 over 600 minus 500 is equals to UAC minus 3112.08. Okay, so you have 3287.99 minus 3112.08. Thus the value of your UAC is equals to 3156 0.06, that is in kilojoules per kilogram, and we have to substitute that here. So we have 3156.06, and those we are ready to determine our UAD, or the internal energy at 525 degrees Celsius and at 2355 kilopascal. Okay, so let's do the vertical. So we have the 2355 minus 2000 kilopascal over 2500 minus 2000 kilopascal is equals to UAD minus, say, 3159.88 over 3156.06 minus 3159.88. So your UAD, okay, UAD is equals to 3157.17 kilojoules per kilogram. So therefore, your UAD here is equals to UAD is equals to 3157.17. Okay, so I will not be solving the HED and the SAD. You do it as an exercise. So hope you enjoy and learn this lesson well, and see you in my next videos. Thank you.